it up for David.
Okay, hello everybody. How are we doing? Ready to rock and roll? All right, so first of all, let me apologize for the jacket. I had headshot day today at Capital Factory, so dressed up. Normally I'm in like t-shirt and flip-flops. Anyway, my name is, all right, here's what we're gonna go through. I'm gonna tell you a little bit about me, see if you care. Tell you a bit about my background, what I do, and how I got involved with what I'm about to show you. I'm gonna give a high-level overview of how all this stuff kind of fits together, because there are a lot of moving parts. And so feel free as we go through this, if you have questions, to go ahead and toss them out. Hopefully we don't get too bogged down. I'll go through some of the specifics in each piece of the architecture and what they do, how they kind of all play together. I'll give you the details on the technical stack that we're working with. I don't see a lot of laptops out. I see just a couple laptops out. So the plan for me is when I go through the live code walkthrough is to do it so that you can, if you want to pull your laptop out, follow along. That's kind of the intent here. I think then we can do a full-on Q&A at the end if you have any questions. So let's dive right in. So briefly, my background, went to a couple schools. Background is in computer science undergrad and MBA in finance. Worked for a bunch of companies, and ultimately that led me to the two logos on the far right, Aktary Tech, which is my consulting shop. We are a node-focused consulting shop that I founded in LA and expanded out here. One of the projects that we worked on as a side project got spun out into a crypto securities trading platform called ERC DEX, which is the logo on the far right. I won't run on more about me. That's just a little bit about my background. Been doing computer science type stuff since 98 or 97, something like that. Okay, yeah, sorry. So let's go through the high level of this. So the big idea here is, let me just see a show of hands. How many people use TypeScript or have used TypeScript? How many think TypeScript is the devil? Really? Yeah. There's some JS purists that just hate TypeScript, and I was one of those until I really got into it, and it converted me. And this is coming from, originally my background was, I'm a Java 2 certified programmer, so I came from C++, Java strongly typed, came all the way around to JavaScript, didn't want to be responsible for typing, and this finally converted me back. A couple of reasons why I became a convert. One is that the developer experience actually does get better. I mean, the tooling really makes your development experience a lot better. And it enables things like what I'm going to demo you today. And originally watching my then CTO, I'll get into who he is, use TypeScript and what it can do, and leveraging that to be so much more efficient kind of converted me. So we'll get into why that is. It's part of my motivation for giving this talk, is because I think it's worth learning about, and it's worth understanding what kind of cool stuff you can get out of it. So the title of this is TypeScript and Tsoa as a source of truth. What is Tsoa? So I would be very surprised if any of you have ever heard of Tsoa before this. Because it's a package that my former CTO wrote. And it is an acronym. How many of you have ever worked in Go? Anybody? Okay, so you know Goa? So it's based on Goa. It's taking the same approach. So Goa is Go-oriented architecture. This is TypeScript-oriented architecture. And so the idea here, never write docs or routes again, just means that you can leverage all the stuff that you've already done, use the tooling given to you by Tsoa to then generate all this other stuff. So traditional docs suck because either you have to write them and you do a good job, but it's painful to write good documentation and keep it up to date all the time, or you don't do that and then it sucks for the reader. So it's going to suck for somebody unless you use tooling to help you. So the next point about boilerplate routes, I don't know how many of you have had to write routes in Express, for example, but it gets just mind-numbing just writing those out. It's the same stuff, and it's just rote, right? So why wouldn't you automate that? So you can, with this tool, you can do that. Philosophically, we're just trying to leverage the idea of using the combination of strong typing with a well-structured application and using logical structuring to design your application. So you've got models, controllers, potentially services on the server side, applying some automation to that combination of structure and getting an output that is therefore consistent and fairly high quality with an asterisk. Feel free to read that on your own. So that's generally the idea. Now, let's take a look at what you're actually getting. What the hell am I talking about here? So I'm going to use an example framework that is sort of a companion and highlights the advantages of Tsoa. And it only has a model and controller. We could also inject services into this architecture and make it a little bit more complex, but for simplicity and for demonstration, I'm just keeping it very simple. It's going to be very contrived. But quite simply, you can take your model and your controllers, and as long as they're well designed, well defined, and you've used TypeScript, you can run Tsoa on them and get your Swagger output, and you get your routes written for you. Now, if you couple that with a Swagger-based generator, you can get now client-side API generated for you, so you don't have to write that anymore. And you can get use another tool like Spectacle to get your API docs, right? So we kind of cheated on the title of this because it should have been using TypeScript and Tsoa and Spectacle, really, to get all this stuff. But I color-coded these so you can see the green stuff or what you get for free, essentially, by applying the blue tools to the white documents. And you write the ones that are on the far left, and you get, actually I should make the Swagger green because that's kind of an output of Tsoa. Is that clear so far? Hopefully. All right, so the tech stack that we're working in, we're going to be using a Dockerized Redis and Postgres. Quite honestly, we do nothing with Redis in this example that I'm going to take you through. We will use Postgres sort of very briefly, just so you can see an end-to-end flow. We're using Node. I'm using 1010. I actually had, just as an aside, how many of you know the Nodejs install error? Do you know what I'm talking about when I say that? I remember giving a talk at Nodejs back when we were on Node 6, I think, or maybe before that, and it was the same goddamn error, and it's still happening. Anyway, what's that? Yeah, exactly, yes, yeah. So I ran into this with putting this demo together. I actually used Node 12, and I ran into the Nodejs error. I was like, are you kidding me, again? So I had to fall back to 1010. But anyway, so we're going to be relying on type ORM as well. Is everyone familiar with type ORM? Well, is everyone familiar with an ORM? Yes, object relational. Okay, so this is specifically for TypeScript. And so what we're going to do is we're going to combine type ORM and some of the Tsoa decorators, as we'll see in the code. And that's going to be sort of the foundation for our Swagger. Express is also in there on the Node side, as well as Spectacle. On the client, we technically have React there. You'll see some React code. I'm not going to be coding in React just because this is a Node meetup. And I just want to do an end-to-end demo. The OpenAPI Client Gen is one of the many tools that you can use to feed in swagger.json, and it'll spit out a client for you. So everyone knows, if you don't know, Swagger, I'm gonna get this wrong. I want to say it used to be called Swagger. It's now called OpenAPI. Is that right? Yeah. Okay. So they still use Swagger.json. I don't think I've ever seen OpenAPI.json, but the file is still called Swagger.json. OpenAPI and Swagger are essentially interchangeable. Then SaaS technically is in there as this Webpack that's running the client web server. Okay, so we're going to switch to the demo. Fingers crossed this works. And if you have your laptops, feel free to follow along as we go through this. I'm going to switch to my ID. Oh, yes. Company folks, can we give out password? Yeah. I believe it's customer obsessed. Yeah. Okay. Yeah, yeah. Yes. Sure. Okay. So, first things first. Sorry. Where did my other one go? There it is. That's why. Okay, so if you're following along, go to this URL. Yep. Oh, of the Slack group, sorry. So this is the example demo application that we're going to fork it in your own repository. Pulling it down. God, what? Okay. Right. I think I already had mine open. Okay, I've already got mine, so lazy do that. Okay, just out of curiosity, so I know when I look up who to look at, raise your hand if you're following along, actually. Okay, cool. Yep. Yeah, I will when I get to something we're looking at. And the other thing that you're going to want to do is go to this URL and grab Spectacle. I'll drop that into here as well. And actually, I take that back. You can do an npm here. You can do an npm install of Spectacle. Just do this guy right here, npm I. They tell you to do it global. You can choose whether to do that, whether you want to do that or not. You don't really need the npm. You don't need the actual code base. You just need to be able to execute Spectacle. Okay. So let's briefly go over the structure of the project, just so that everybody knows what we're looking at. So VS Code, this should be pretty straightforward. I use VS Code. I don't know if everybody else does. I actually really like it for Microsoft project. I'm shocked, but that just configures the VS Code IDE. API is where all of our server-side magic is going to happen. That's where all of our server-side code lives. Dev is actually the sort of glue that runs everything. So I'm not going to take you through this right now, probably. But if you're curious as to what kind of craziness is going on when you actually kick this off, take a look at Start TS and it'll explain, like you can look through the actual process. And then web is where the client side is going to be served from. So all of this could be separated out. You're going to have to, if you do choose to separate this out into different machines that are serving and doing different purposes, you're going to have to parse out dev and make sure that that you're not breaking things. You probably will. All right. So first things first, I need to need a yarn. Get everything. Nope, that's not going to work because I have to use 10. So while that's cooking, okay, got everything up and running. Okay, can everybody see okay? Is that big enough? All right. So in here, what I'm going to do is I'm going to install, let me see if I have Spectacle. I've already done npm global install on Spectacle, so I should be able to run Spectacle. I'm going to do Control D, so it actually runs and watches for changes on my Swagger file. And my Swagger is going to be set up, I believe it already has one in here. No, it doesn't. All right, so I have to actually run this once. So Tsoa is being called under the covers, and you can see that it's running the startup scripts here. And it generated, okay, here we go, generated open API spec, generated client, generated express routes. Right, so those are all happening. I did a yarn start, and all that calls is this, which is that dev, start on the dev script. So it's going through here. I might as well show this. I did prepare this as a backup. It's going through here and running through this as the build process, the kickoff process. So it's calling yarn start. Start is going through and doing all of these things. Starting Docker, so it spins up Postgres, spins up Redis, generates the routes, generates the API, generates client API, and registers a quick key, so I can just do a Control-C to kill everything. And then it's watching for changes, and if it has to regenerate, it'll regenerate. Notice I haven't written a line of code yet. So, and when I do, all of that will be happening for me in the background. So now, because it's generated the Swagger, which, by the way, got dropped over here under dist, swagger.json, my Swagger definition file. Sorry, I've assumed people know this. Does everyone know what a Swagger file is? I shouldn't make that assumption. Who does not? Let's put it that way. Okay, okay. Please stop me when I do stuff like that. So a Swagger file is a file that describes in JSON the structure and nature of an API. That's what that is. So it is in a JSON file, a description of exactly what the endpoints are, what they take, what they return, all of that in a sort of uniform way. Okay? So now that Tsoa has generated this for me, because it looked at the TypeScript annotations throughout my code, it's looked at, I'll show you this real quick. It's looked at my widget controller, and it said, okay, well, here's a route. This, by the way, is a Tsoa annotation decorator. It says, okay, this widget controller needs a route. It's going to be /widgets. And we can make get calls to that route. And we're going to, when we document this, we're going to have a widgets tag. Okay, does that make sense? So it knows to use this controller. When it generates the route, any requests that come in making a get call to this widget's route, it will send to this controller, this class. And then it will send it, I said that exactly wrong. Anything that comes into this route and makes a get request, it'll send to this controller. Right now it's not doing anything, right? It's just returning right back. But we can put logic in there pretty easily. So this is another example, this method below it in the class. When someone makes a get request with an ID, with a widget ID, it'll make a call to this controller and find that particular widget and return it or throw an error, right? It's just template code that you can strip out, but it shows you exactly what these decorators have done, are used for, and how they work. So now we can run Spectacle since we have our Swagger file, and we could say, nvm something. Okay. And I said we're in dist, API dist. There we go. So now what this is going to do is Spectacle is going to go grab that Swagger file and basically just give us documentation back. So it's generating all the docs for us. It should finish here any second. It is, but I think it was kicking out I'm ready now. Oh, I was looking right at it. Never mind. All right. So we go to localhost 4040. Was it 440? And lo and behold, there's our documentation. So that's pretty cool. Now, where'd all this come from? Any guesses? It's TypeScript. TypeScript gives you that, right? So it just read TypeScript and said, okay, well this is the kind of thing we're returning, right? So we can see that over here. That's an interface. That kind of makes sense. That's why we call them interfaces, right? So that's how it knows to tell you what you're getting back. So now we're gonna try and dive into making some changes here and see how this adapts. So the other thing I want to show you before I get into that is what happens when you actually run this guy. We have it running. We do have it running. Okay. Sorry. So when you actually run the app, this out of the box app, it is really unsexy. That's it. right? There's nothing exciting going on there. What you got was widget 1 with what color it is and the name, which is not shocking. That's our default widget that was in here, right? And it just got kicked back. When you load the default route, it pulls up just all the widgets that you've got, so it returned everything here, right? We haven't looked at the front end code, but that's all it does. So what I'm going to do now is I'm going to take this, which is a commented out model, and in TypeORM, the way that you use TypeORM, and this took me a while to kind of get comfortable with, but once you're there, it's pretty cool. You define your database in TypeScript, and TypeScript then goes and creates the database for you, handles everything for you. So if I uncomment this, this is basically telling TypeScript, I want an entity, which is essentially a table, called users, and I'm giving it a special name users, otherwise it would take this class name. And I want one field on here called email, which in the database will be a text field. And depending on your database, you can have different types of columns. So you have to go to TypeORM documentation to figure out what that should be. For our purposes, for really no reason whatsoever, I'm going to give users a first name and a last name as well. So first, if I could learn to type, it would be really helpful. Okay, so that's it. We just have this new entity called user, right? Okay, now I've saved the file, and note that I haven't actually created the database table yet. There's a separate process called creating migration that needs to happen to actually create the table in Postgres. Okay. However, I believe I might put myself on this. Reload this guy. I might have to rerun some. Might have to rerun everything. Right, I do have to rerun it because well, the Swagger should have generated. Sorry. So I'm not here to show off the watch function. It may not be watching properly. Yes, so Tsoa will pull that. You'll see the entities. Yeah. See right here, schema definitions. That should see. I don't know why that's not showing up. But that's not it. Well, all right, let me just finish this stepping through it. So all right, controller. Let's go to the controller. So this is the longer code bit. I'm going to create a new controller. I'm just going to copy and paste this guy. Try and do this quickly, apologize. Quick find replace. hopefully I don't regret doing this in mass. Guess we'll find out. I did it manually when I first ran through this, so. Let's see. Looking okay, okay, everything's okay. Okay. So we've got a new controller there. And we want to be able to pull data out of the database and leverage TypeORM and get full end-to-end data flow, right? So let's kill that and say users is going to come from our database. And I actually had a bit of a hiccup here, so give me 1 second. I have to refer back to my previous version so that I don't reproduce that problem. In fact, you know, I'm just going to cheat and copy paste. So yeah, our interface is going to change with the user, right? Because we defined a first, last, and email. Here we go. There was a bit of a weird thing with how I was pulling the repo, and I didn't really have time to completely debug it, so I had to work around it. And this code, I will be putting this code open up on my GitHub, so if you want to see what I did, it'll be available. I think I've got it. And so this is complaining because I'm not importing anything from TypeORM, so all of these need to come in from TypeORM, which I'm going to do now. And then I'm going to cheat. There is one other call to a initialization, database initialization, just to sort of as a backup, because it's part of my workaround hack. And we've got to get a reference to our database entity user. It's our TypeORM user. We should be good to go. There we go. So now, the last step is we've got to tie this into the overall application, because the application doesn't actually know about this yet. We've got to actually import it into our server. So here, stop alphabet. Alphabets are hard. Okay. Now, all I've changed is controller code. I haven't written any routes. I haven't written any documentation. It's all been done for me. I'm probably gonna have to rerun this guy. This doesn't seem to be going. There we go. Yeah, had to rerun Spectacle. Sorry about that. I could swear it was updating in real time last time, but whatever. Anyway, so now we've got all of our user-related stuff in here. We've got our user routes, right? Just automatically, we don't have to document any of this stuff. It's pulling in the response information from our TypeScript definitions. Of course, you can beef this up a lot more if you wanted to. And you'll have to delve into how Spectacle works to leverage some of the stuff that they give you. But this is a great way to get things started. So for completeness, I guess I will quickly do the migration so that you can see what that looks like. So I have to remember what the semantics are here. Yeah. So db migrate, this command is telling TypeORM basically to create what's called a migration. So this is kind of an aside, but if you've never used TypeORM, essentially what it does, it takes a look at your TypeScript defined model and it generates SQL for you. And that SQL then will be what gets updated in Postgres or whatever your database is. So I'm telling it to create the SQL file with this migrate command. I'm going to call it users. Okay, so oh, I already have a database table named users. Okay, give me a second. Let me kill that guy. Let's see if I can quickly refresh this. Yes. And actually, I'm going to drop the migrations as well. This is how TypeORM tracks its migrations internally. Using a migrations table. Drop both these guys. And try this one more time. Users. And actually, that conflict, by the way, just to clarify, probably as clear as mud, the fact that I named the migration users isn't what caused the error. What caused the error is that our model entity we called users. That's what caused that error, conflicted with the existing table. Okay, so now we have our migration. You can actually now look at the newly created migrations directory and actually look at the actual SQL that gets run. Using TypeORM, you can back out any changes. So the idea here is that you incrementally change your database and you can back out any changes that you're creating. So now that I've created the SQL, I want to actually just run that so that it actually goes into the database. And I think that was yarn db run. No, it wasn't. It was yarn update. Okay, so now we have a database sitting out there, hopefully, with the table that we want. I'm going to refresh this guy. We should see both migrations and users here. And we do. And it's empty. That's not the right one. This is the old one that I had. Let's try that again. Users. New data. Should be empty. It is empty. Okay. But we have our fields. There's our email field. There's our first field. There's our last field. So that's what we expected, right? As an aside, some of you may have noticed that when we were defining that model, it actually inherited, that class inherited from a base class. I don't know if anybody caught on with that. So user is actually extending base entity. So TypeORM is kind of cool in that way that you can extend, you can use inheritance in your database definition. So base is where the ID date created and date updated came from. That's where these fields are coming from. Make sense? So I'm just going to give this an ID of 1 and give a date of today, which is 7/17. So and let's pick something better. Probably butchering her name. Something along those lines. Okay, and yes, I'm totally cheating here and not actually doing a write to the database through the application, but I figure we have to time box this thing, so I'm writing directly. Any DBAs that are having strokes right now, I apologize. But now we've got our data in there, we just got to get it back out. So flip back to our application and we go, by the way, notice this public thing just showed up. This showed up when I ran Spectacle. So Spectacle creates this public folder. You can put that wherever you want. Spectacle actually runs its own server under the covers, but you can just rip out the HTML and put it up somewhere or whatever. You can tool it however you want. So here, by the way, here's our API on the client side. Note I didn't write any of this code, but all the code that we need is in there. And hey, there's our user code. That's pretty cool. Right? So I don't have to worry about gluing my client-side API to my server-side API. It just does it for me. Right? So in my index, no, my app, there we go. Again, I'm just going to cheat and copy paste here. So all we're going to do here is add user to the state so that React so that we're finding that in our state interface. And just for funsies, I say, okay, well, don't only show the loading thing if we, or don't show the loading thing if we have, only show the loading thing if we don't have everything yet. And then pull this. What are you complaining about? Not grab everything. All right, let me see. What am I missing? Yeah. Then this is our API call. So here we're making a call to the user service, get user, and this is going to be defined by Tsoa, right? It's basically looking at our controller structure and just kind of mimicking that. And then here we're going to just set state for user. Good. That should be everything. I don't know why this is a problem. Anybody see anything I'm missing here? I'm not sure why this is complaining and the other one's not. Sorry? It's complaining about both of the things in state, which it shouldn't. It's saying it's possibly undefined, but yeah, it's gonna break. Yeah, it's weird. I didn't have that earlier. It's got to be this guy up here. This is the short circuit logic. Why is this? All right. Yeah, that it shouldn't matter. Like it should be fine, because even so, when we get down here, it should short circuit, right? Sorry. Yeah. Oh. Thank you. Yep. I knew there was. It's always the smallest things. You're like, wait, but oh, fuck, of course. All right. Right. Exactly. That's when it happens. Okay. So I mean that should be it. So there we go. I didn't even have to do anything. So it just auto reloaded, and there's our data directly from our database all the way through. Exactly. Thank you. That's a great point. Yeah. That's why you use TypeScript. That like it's stuff like that that I don't even think about it now. That TypeScript is awesome for. It's not just leveraging through developer flow tooling to like generate artifacts. It's just where did I miss a semicolon? Not semicolon. Where did I mistype something? Right. Yeah. So that's pretty much it. The last little bit, I probably should have shown this earlier, but in case there's confusion of how all this kind of stuff flows together or fits together or whatever, got a little deployment diagram. Hopefully we'll have all the slides and everything up where you can review this if you need to kind of noodle on it. And that's it. Questions? I'd see everyone seems to still be awake, so that I count that as a win. Any questions? Yes.
So because you're kind of using so many different tools in concert there, at a high level, like if you rip Tsoa out of that equation entirely, what are the things just kind of have to
yeah. I'll go back to the slides so I can just refer to things visually. So if you rip Tsoa out, that's kind of what I was thinking with this is like Tsoa gives you your swagger.json and it writes your routes for you, and your swagger.json sets you up for all the other stuff, right? So you're then manually creating that, or maybe using another tool. You can use it. There are other tools out there to create Swagger files for APIs. I mean, Swagger itself or OpenAPI itself, if you write it in a compliant fashion. But you get the routes as well. And I think that's valuable. And it sets you up for the client generation and everything. Yeah, but you're right. There's a lot of tools being stacked together here. But that's kind of the beauty of it. It's because if you just take this and understand the stack and rip things out and get good at figuring out what's missing, then your productivity can go through the roof. Other questions? Was that too high level? Okay. All right, guys. Yes. Yep. Right. Right. Yep. Yep.
So I'm like, okay, this help us fix the bug monolith. But now you have this like 67-second build step.
Yeah. Yeah, I mean, it's a trade-off like everything else. I think I haven't seen, I mean, so I showed you our little demo app. For ERC decks, we have a much, much larger code base. And I haven't seen anything that would concern me, but you definitely have to be careful because when you start mixing tooling, some things may be expecting JavaScript and you're in TypeScript. And, you know, as soon as you start mixing Webpack and all these other things, you got to make sure everything's just right. But from a performance standpoint, I haven't noticed anything that would cause me to not want to use TypeScript yet. Yeah, both, yes. Both, yeah. So, in fact, I think even in this, I guess you can't see this. Yes, you can't see it. In this example file, we have exactly that. At least I thought we did. Yep, yeah, we did. So, other questions?
So in a platform, a lot of times you have a dedicated through a way to pull down the model from the database to generate the model in TypeScript and then forward that to Tsoa to.
Ooh. Okay, the question was, in an enterprise environment, you have DBAs who have been building the databases in the database, and can you take that, essentially the database schema, and create type ORM models? I don't know of a way to do that, but that's not to say that it doesn't exist. It wouldn't surprise me if you could do that. I mean, it seems like something that should exist, but I have never had that problem, so I've never tried it. It makes a lot of sense to have something like that. I mean, it's fairly deterministic both ways, right? So if it doesn't exist, you could probably build it. True. True. Yeah, true. DBAs could just run the tool, whatever it is, and it pulls the schemas and creates the type ORM definitions. Yeah. There probably is such a thing. I'm not aware of it. Anything else? All right, guys. Thank you.